Hi friends, welcome to the Unit 2 Day 4 notes, talking about domain range and implied domain. So if you have, really you always assume that you're going to be using all real numbers. However, if you have a rational expression, that gives you a 0 in the denominator, or if you have an even root expression, then you don't want to have a negative radicand. So what we want to do is we want to look at this and say, okay, well what's going to be the actual domain of this? So for number 7, we can't divide by we can't divide by 0. 7 is actually a listing of the domain from number 6 above. And in interval notation, that's the notation that we used. So we can't divide by 0. So if I set the denominator not equal to 0 and then solve, I get -2, and I can't have -2. So I can have any other number I want except -2. For number 8, we set that greater than or equal to 0 and then solve. So for this one, 2x plus 3 is greater than or equal to 0. Minus 3 on both sides, you get 2x is greater than or equal to -3. Divide by 2. X is greater than or equal to -3 halves. So interval notation, so we're going to start at -3 halves inclusive and go to infinity. For this one here, again, we can't divide by 0, and so I've set the denominator not equal to 0 and then solve. X squared minus 9 can be factored into x plus 3 and x minus 3. So this tells me that I can't have -3 or 3. In interval notation, so I can have -infinity to -3, non-inclusive, union, -3 to 3, union, 3 to infinity. For 10, this is a quadratic. It does not matter what's happening with the particular quadratic, because what we have in this case with this x squared minus 5x plus 7, that quadratic, it doesn't matter what the domain is. We can plug in any number we want. So this is from -infinity to infinity. Number 11 and 12 are a little bit more difficult. Joining us, it's basically essentially a combination of things. So I can't have the -3, so that's an issue. So you can't have the x value being -3, but you can't have this entire thing. You have to set that greater than or equal to 0 and then solve as well. So 7 over x plus 3 is greater than or equal to 0 and then solve. So for this case, when we go through and we find the value, normally we want to multiply by x plus 3 on both sides to kind of get that part, to get that out. The issue is if I multiply x plus 3 on both sides, I get 7 is greater than or equal to 0. So this particular type of example or problem, it's a good one to graph and kind of see visually what's going to happen. So if I take the square root of 7 divided by, then in parentheses, x plus 3, close parentheses, let's see graphically what happens. So we get an actual value or a point where this starts, and because it's a square root, it gives us that square root value, but it looks like it's almost inverted or flipped. So the kind of value to see here is what happens when x is -3. Well, I can go to my table we talked about earlier, and if I see it -3, it gives me an error. In fact, if I scroll up from -3, there are no other values that work. This actual graph begins right just past -3 and then continues on. So for this one, my domain for this one is -3 non-inclusive and then to infinity. Normally when we have a denominator in this case where it's just, kind of set up as just x plus 3, if I didn't have the radical, then we would have a situation like we had up here with number 7. But because of the radical, we can only be greater than this value. So kind of a way to see that is, because of what we had over here setting it up, we only have greater than that value. In this case, greater than -3. Similarly with this one, we would set the denominator not equal to 0 and then solve. And then also setting it greater than or equal to the underneath the radical. So 4x plus 5 is greater than or equal to 0, minus 5, minus 5. 4x is greater than or equal to -5. Divide by 4, divide by 4. So you get x is greater than or equal to -5/4. But remember, we can't have this being 0 under the denominator. So this is what would make that 0. So instead of just being greater than or equal to, we're actually just going to say x is greater than -5/4. So again, that radical essentially takes out that equal to part and just lets us use the greater than component. So this is going to be from -5/4 in this case to infinity. Function notation. When a function is defined with a rule or an equation using x and y for the independent and dependent variables, we use function notation to show this. Function notation is f of x. So we're going to say let f of x equal negative x squared minus 6x plus 4, and g of x equal 3x plus 1. Find and simplify the following. F of negative 3 means that wherever you see an x in the f equation, you plug in a negative 3. So for this case, you have opposite, negative 3 squared minus 6 times negative 3 plus 4. Negative 3 squared is 9, so I have negative 9, because that negative sign out in front, plus 18 plus 4. 9 plus 4 is 13. Do equal signs here. It says f of r. Well, r, what's r? Well, in this case, r is just r. So we have negative r squared minus 6r plus x. Wherever you see an x, you just put in r. That's it. G of negative 2. So if I plug in negative 2 in for this one, I have 3 times negative 2 plus 1. 3 times negative 2 is negative 6. Negative 6 plus 1 is negative 5. So sometimes you get, if you just have a number, then you will end up with just a number in your answer. If you have a variable, then you have a variable in the answer. This one is a variable and a number, so you'll have both. This one, g of r plus 2, so that means wherever you see an x, you plug in exactly what's here. Good thing to remember is that if there's parentheses, then you need to have parentheses here as well. So this is going to be parentheses r plus 2 and then plus 1. That's going to be 3r plus 6 plus 1, or 3r plus 7. And the last part of the video talks about a piecewise function. This one is a different part of a piecewise function. So let's look into the graph. This is a graph f of x. For this to be an actual function, we need to make sure that we talk about what's happening here and here. So I closed this dot, opened this dot, and this, I'm telling you that the graph goes on forever in those directions. What is the value of f of negative 2? So that means I look at this graph, f of negative 2, that's this part right here. Now, be careful, this is 1, this is going to be half. So this, when f is negative 2, that value that you get is 0.5, or 1/2. What is the value of f of 1? So again, when I plug in 1, looks like my value is 5. Now I'm asking a different direction. What values of x satisfy f of x equals 2? So in this one you're looking at here, what values, okay, well this one doesn't. Be careful, this is an open dot. But down here, 4 does satisfy that. And then satisfy negative 2. Looking at this, looks like I have this value here. This one's kind of hard to see. This one is exactly halfway in between this and this. This is 4.5. That would be 5 here. So that would be about 4.75. I'm not 100% confident, so I'm going to just put that there. Thank you for joining me in this video. See you in the next one. Have a great day. Bye, friends.